Today I'd like to go over a proof of this limit here as x approaches 0 of cos x minus 1 over x. For this, we're going to start with the limit that we're trying to evaluate. The limit as x approaches 0 of cos x minus 1 over x. And the first thing that we're going to do is multiply the numerator and the denominator by cos x plus 1. Something just like this. And the numerator, after we FOIL this out, we're going to get the limit as x approaches 0 of cosine squared of x minus 1. And in the denominator, well, we're just going to have this whole thing, x times cos x plus 1. Now we can use the Pythagorean identity to substitute this in terms of sine. So recall that sine squared of x plus cos squared of x equals 1. Here we have cos squared of x minus 1. So let's subtract 1 from both sides. So that here we have cos squared of x minus 1. And we'll get that in terms of sine. So we'll also subtract sine squared of x from both sides. And we get cos squared x minus 1 equals negative sine squared of x. And this is what we're going to plug in here. Getting a little messy. But we have the limit as x approaches 0 of negative sine squared x over x times cos x plus 1. Here is where we're going to split apart this limit into two limits that are multiplied by each other. So here's what we're going to do. We're going to have the limit as x approaches 0 of negative sine x over x times the limit as x approaches 0 of sine of x over cosine of x plus 1. Now, we just split apart this fraction into these two. You can double check because if you multiply these fractions together, you'll end up with what we started with. And we're just now taking the limit of both of these fractions separately. This here, we can write the negative out front. We know what this is, the limit as x approaches 0 of sine x over x. I have a different video on this if you're curious. This right here is just 1, and it's negative 1 times. Here, I forgot to write a 0. No way. We have the limit as x approaches 0, and there's nothing wrong with just plugging it in. So let's do that. Sine of 0 in the numerator is just 0. So I'll do a little aside. 0 over cos of 0 is 1, plus 1 is 2. 0 over 2 is just 0. Now we have negative 1 times 0 equals 0. And that's a short proof for this fundamental trig limit. Hopefully you found it useful, and have a great day.